Good morning to everyone. Today we are going to discuss about CNN architecture. Myself Arshila Devi, Assistant Professor in Rohini College of Engineering and Technology in Department of Computer Science and Engineering. So in this lecture we are going to discuss about CNN architecture. Okay, first we are going to discuss about CNN architecture overview. In general, convolutional neural network consists of four major components: input layer, which receives the images; convolutional layer, which extracts the visual features like edges, textures, and shapes; pooling layer, which reduces the spatial dimensions and make computations faster; fully connected layer, which performs the final classifications. Next, we are going to proceed to see how these layers come together in famous architecture like LeNet, AlexNet, and VGG, ResNet, and more. Okay. Next is functions of CNN layers. The main functions of CNN layer, the purpose of CNN layers are the convolutional layer, which learns filters that detect important patterns in the images. The pooling layer downsamples the feature maps using techniques like max pooling or average pooling. And the fully connected layer integrates all the learned features and produces the output. All these layers are trained through backpropagation using gradient descent, enabling the network to learn from the data. Next, we are going to discuss about different CNN architectures. First one is LeNet architecture. It is one of the earliest and most influential CNN architecture. It is introduced by Yann in 1998. It is especially designed. It is mainly designed for handwritten digit recognition on MNIST dataset. LeNet uses simple combination of convolutional, pooling, and fully connected layers. This model proved that CNN are highly efficient for image-based tasks. Next is AlexNet architecture. This AlexNet architecture, which won the ImageNet competition in 2012 and revolutionized its revolution on deep learning. It uses 5 convolutional layers and 3 fully connected layers. AlexNet introduced an important innovation such as ReLU activation, which speed up the training, dropout, which reduces the overfitting, with around 60 million parameters. AlexNet showed that deep CNN could be trained a large scale of GPU. Next is ISFNet. ISFNet is introduced in 2013, improved by AlexNet by modifying the filter size and the stride to extract the features more efficiently. It uses fewer parameters but achieves better accuracy. ISFNet is also introduced in deconvolutional visualization, helping researchers to understand what each layer sees. Next is GoogleNet or Inception architecture. In 2014, Google released GoogleNet and also known as Inception V1. It is a main combination of Inception module where the multiple filters of sizes 1x1, 3x3 and 5x5 operate in parallel. This architecture also uses 1x1 convolutions for dimensionality reduction, making the model deeper yet computationally efficient. Instead of fully connected layers, it uses global average pooling, reduces model size dramatically. Next is VGG net architecture. VGG developed at Oxford University focus on simplicity. It uses only 3x3 convolutional filters but stacks them to create very deep networks, that is 16 or 19 layers. Then VGG architecture also highly popular for transfer learning as their features extraction capabilities are generalized well across different tasks. Next is ResNet architecture. ResNet is introduced by Hamming in 2015. It solved a major problem in deep learning, that is the vanishing gradient issue. It introduced residual block where the input is added directly to the output block through the skip connection. It allows network to grow extremely deep, that is 101 to 152 layers. So ResNet become a breakthrough in deep learn training. And next is mobile nets. As mobile nets and embedded system grow popularity, the researcher developed mobile nets, which are lightweight CNNs. Mobile nets use depth-wise separable convolutions, which drastically reduce the computation. They are optimized for low latency applications like smartphones, IoT devices. And next is GoogleNet and Deep Dream. Deep Dream was developed by the Google researcher as a way to visualize and amplify the parameters learned by CNN. Given an image, the model extracts the detect the features, producing artistic and dreamlike visuals. Through not a classification model, Deep Dreams helps us to understand how CNN interpret the patterns. Okay. So this is about the basics of CNN as well as different architectures of CNN. Thank you.